Hello students, welcome to PW Gulf. I am Tanya and today we are going to talk about properties of fluid. So when you are going to study gravitation chapter, half portion is aligned towards properties of fluid. Over there you will understand what is pressure, how pressure is exerted by fluids. So in today's class, this is nothing but a one shot where we are going to complete pressure exerted by fluids, buoyant force and buoyancy. So without any further ado, let's start with your first thing, that is nothing but pressure. But before talking on pressure, yes, I have a question for all of you. So all of you, I believe you have been to a fair or you have seen a picture that where acrobats, they are standing on a nail bed. Over here the same scenario is there. There is a boy standing on a nail bed. My question is that will the boy feel this pain as the boy is standing on nail bed, as you can see over here? Yes, he is standing on nail bed. So yes, boy should feel this pain because nails are pointy, right? But in this case, if you think, there are some scenarios where you observe that okay, very comfortably acrobat is standing. So my question is simple, that will the acrobat feel hurt while standing on a nail bed or will feel this pain while standing on the nail bed? Think yes or no. So these are your options. I want the answer there in the chat and certainly I will have a look onto it. Okay, so think and answer that will the acrobat feel this hurt or pain onto his or her leg? So some of you will say yes, some of you will say no. Now, the correct answer over here is no, the acrobats are pretty much comfortable. How is that even possible? Let us compare this whole scenario to the case where acrobat is standing on a single nail. If acrobat is standing on a single nail, yes, it is very dangerous and I will advise all of you, please don't try this thing at your home also. Reason being, if in this case acrobat is standing, the nail is going to pierce through his leg and of course it will be dangerous. But in the similar case with the nail bed, you are going to see that yes, he is standing comfortably over here. Why this discrepancy? Over here one nail. In this case you can say 100 nails. So what is the difference between the two? The number of the nails first of all. Second thing over here will be that yes, as we can see here, area of contact, as you can see over here, area of contact is less. And in this particular case, because there are a lot of nails, area is more. So how this area in contact, moreover the force exerted by your acrobat here, it is nothing but weight, how it is working upon, and difference we can see. Yes, we are going to understand about this thing only, the term, the effect that you will see, that is nothing but pressure. So all of you, let's take a one example over here. I am giving you a nail and I am giving you a bat. I am telling you, hammer the nail onto the wall, hammer the bat onto the wall. So here in this case you are going to say, ma'am, okay, I can easily hammer the nail onto my wall and the nail is going to go inside the wall. Let's say this is the wall. Okay, but in this case, if you are going to hammer the bat there onto the wall, what will happen? The wall is going to break, right? And certainly you will get scolding from your mother and father that, okay, what you are doing? Yeah, this case also you are not going to do at your home. So, what I am trying to convey over here is, everyone, when you are applying the force onto the nail, yes, nail is going inside the wall. But when you are applying force onto the bat, yes, your bat, either the bat will break or the wall will break. You are applying force. So why difference effect? Why this a difference in the effect? Of course, over here the point to notice is area of contact is also playing a very vital role. So everyone, this effect that we encounter around us, that is nothing but your pressure. So all of you, whenever you will talk about pressure, pressure is nothing but force acting over a particular area leading to different effect. Okay, so when I am saying force applied onto a particular area, that will certainly give me some effect, that is nothing but your pressure. Okay, so for pressure, two things are very, very important. What are the two things? Force and area. Both are equally important. And these two factors, they play a very, very vital role. Now, when I am talking about force over here, certainly over here, have a look. Let me give you the whole scenario. Over here, have a look. There is a wall. Okay, and there is a nail. Right? Okay, now when I will hammer the nail, what will happen? I am applying force. Can you see? Right? I will hammer the nail. Yeah, I am applying force. Force over here that is acting onto the nail. Can you see? It is 90 degree. Yeah, so either you can call it as force or you can call it as thrust. Kids, thrust is nothing but force acting 90 degree. The force that is acting 90 degree to the surface, perpendicular, or you can say perpendicular. Right? So this term thrust you are going to see a lot, that okay, what exactly thrust is. I am just giving you the hint right now only. Thrust is nothing but force that is applied onto a body, and that force is 90 degree. Now in this case you can ask me that okay, you can apply force, yeah, at certain angles also, no? So if I tell you that okay, over here nail is there, yeah, and you can apply force at certain angle. Force 1, let's say force 2, and this is force 3. So all of you, all these are forces, but only thing, thrust, the special term will be given to only F2. Why this special term is only given to F2? Reason being that yes, this force is acting perpendicular or 90 degree from the surface. 90 degree specific, that is why only thrust. Okay, pretty much clear. Now, when two factors we are talking about, force and area, they are playing very, very important role and vital role in order to talk about pressure. So, all of you, yes, the formula will come out to be force over area. Yes, area over which force is acting. You cannot take any of the area. You have to be specific that yes, pressure is nothing but force by area. This area is very important. Yes, this is the particular area where you are applying force. Okay, be it small, be it big, that we are going to have a look upon. Right? Now, in this case, you can say thrust by area, totally fine. Yes, you can use that formula as well. Yeah, now pressure is nothing but a physical quantity. Physical quantity, they require unit. So, what will be the SI unit for pressure? Let's have a look on that. So, everyone, when we talk about the SI unit, right, for pressure, it comes out to be nothing but Pascal. Okay, Pascal. Right? But now, have a look on the formula. I believe all of you remember also that whenever we talk about the unit of force, it is nothing but Newton. And unit of area will be meter square. So, from the formula, you are getting a unit as Newton per meter square. All of you, 1 Pascal will be equal to 1 Newton per meter square only. Yes, sir. SI unit is Pascal, but certainly they can ask you, they can give you some values in Newton and meter square. Of course, you need not get confused over there. Okay, so yes, Pascal will be the SI unit. Of course, when you talk about the proper unit that you can deduce from the formula, it is Newton per meter square. Okay, I hope till here clear things are and you are comfortable. Yeah, so whenever I am using this term pressure, we are saying force per unit area of the surface acting in a direction perpendicular. Can you see? Direction specific, yeah, they are actually specifying, okay, thrust. Okay, so they are being specific over here. Right, now when we say that, okay, pressure is there, without solving a numerical, we cannot move ahead. So, let us have a look on a numerical. Let us solve the numerical all together. I want you to pause the video and try this numerical and certainly check your answer. Okay, so the pressure of a gas contained in a cylinder with the movable piston is 300 Pascal. So, write down pressure is given to us, that is 300 Pascal. Okay, area is also given to us, that is 0.5 meter square. They are now asking about the force. So first of all, you should know what is the formula. Formula will be nothing but pressure is force by area. Okay, so force will be pressure into area. What is pressure? 300. What is area? 0.5. Remove the decimal, cancel it out. Of course, you can get the answer as 150. Now, I am stopping over here. Reason being, kids, 150 Newton, 150 Pascal. Which one will be the perfect one? What they are asking? Force or pressure? Force, right? So, 150 Newton. So, A is the perfect answer. Right? This is how questions can confuse you. You have to be very, very specific with the values as such. Okay, now moving ahead. So, everyone, I know pressure is force by area. Ma'am, of course, it is a formula, right? But very difficult for us to understand. How we can memorize it in an easy manner. So, everyone, I have a trick for all of you. What you need to do is just draw a triangle. Okay, draw a triangle. And divide the triangle into 3 parts. Okay, horizontal and vertical. Yeah. Now what you have to do is just remember a small acronym, that is PAF. P-A-F, PAF. Yeah, P-A-F, PAF. Okay, now horizontal line over here is nothing but our divide. Vertical line is multiply. Whatever quantity you have to now find out, in the question they can ask you anything. Yes, you just need to simply hide that portion. For example, if I am asking about find out the area, what you are going to do? Hide the area portion from the triangle. What is left in the triangle? Force divided by pressure. Have a look on the formula. Area is force by pressure. Easy. Similar way, they are talking about find out pressure. Hide the pressure portion from the triangle. What is remaining? Force by area. Pressure is nothing but force by area. Okay, last one, they are asking about force. Hide the force portion. Now, have a look in the triangle. Pressure into area. Formula for force is pressure into area. So, by using this particular triangle, yes, you can find out any of the quantity, any of it that you need. These 3 formulas you need not memorize. Okay, so trick is going to help you. Okay everyone, I hope till here clarity is there. Now, let us have a look on a simple scenario. Everyone, I told you force and area, they are equally important. So, let me give you that how pressure is depending upon force, how pressure is depending upon area separately. Okay, let us take up one example. So, I am having one box A and I am having another box B. Both are there and both are having area as 10 meter square. Both are having area as 10 meter square. Okay. Now, force acting on box A is nothing but 50 Newton. Force acting on box B is 500 Newton. You have to tell me pressure exerted at A, pressure exerted at B. Very simple. Use the formula force by area. Force by area. So, force is nothing but 50. Area is 10. It will come out to be 5 Pascal. Okay. Over here, force is 500. Area is 10. Now, pressure is coming out to be 50 Pascal. Everyone, force is coming out to be 50 Pascal. Everyone now notice, area is same. Force is different. So, can you see over here? When area is same, force is less, pressure is less. Force is more, pressure is more. So, can I say pressure is directly proportional to force? Can I say that? Have a look. Yeah, more the force, more the pressure, less the force, less the pressure, area is same. So, area is not giving any such input. Yeah, so we can say yes, pressure is directly depending on force when area will be equal. Okay, now in this particular case only, if I will ask you that, okay, I am having 2 boxes. Now have a look over here. Okay, box A and box B. Area of box A is 1 meter square. area of box B is nothing but 10 meters square. Okay, force acting on both the boxes is 10 Newton. Right? Now find out the pressure. Over here pressure will be 10 by 1, that is 10 Pascal. Okay. Over here pressure at B will be 10 by 10, that is nothing but 1 Pascal. Now everyone notice, more the area less the pressure. More the area less the pressure. Right? Over here lesser the area, more the pressure. So can I say my pressure is depending upon area, but inversely. On this and on these two, there are ample of applications that we are going to have a look upon. So when I say that okay, pressure is depending upon force directly, and when it is depending upon area inversely, keeping the scenario here in the area portion force is same, and here in the force portion area is same. Right? Now let's talk about some applications, everyone. So when I say that okay, there are certain applications, I believe you all have heard that we prefer broader strap bags when we are going to school. Why so? When we talk about broader strap bags, okay, broad strap, yeah, what they will do? Their area is more. Okay, now everyone, if more the area, pressure will be less. So yes, on your shoulders, you are not going to feel that much weight and you are not going to feel that much pain, and you will be comfortable because yes, you have to carry your heavy books to school. Okay, heavy notebooks to school. That is why broad strap bags are preferred. Similarly, there on the tractors, we prefer that okay, the tires, they are wider, they have wider area, not very thin tires like cycle tires. Why so? Because yes, tractors weight is more, and when it has to move there onto sand or some muddy place or there in the farm, of course it need to move comfortably. So more the area, less the pressure. That is why we prefer the tires to be very broad enough. Okay, talking about that, okay, if I give you a sharp knife and if I give you a blunt knife, which knife you will prefer in order to cut fruits? Of course, sharp knife. Why so? When you talk about sharper knife, area is less. If area will be less, pressure will be more, and certainly over here you will be very comfortable in cutting the vegetables or cutting the fruits. Okay, there are ample of more applications that you can explore around you. Certainly with this, we are going to move forward and talk about pressure exerted by fluid or fluid pressure. Everyone, the term fluid, first of all, understand. Okay, there is a huge misconception that fluids are only liquids. No, fluids are liquids and gases both. Why so? Because yes, fluid, the term fluid means anything that can flow. In science, this term actually means anything that can flow. And yes, your liquid and gases both can flow. So anything that can flow is nothing but will be your fluid. Okay, so when we talk about fluids, yes, fluids also exert pressure. Fluids exert pressure in all the direction. How is that even possible? So everyone, I believe you might have seen that okay, whenever we are going for scuba diving, we are wearing special scuba diving suits. Or if you swim, you can certainly feel that when you are going deep down there in the sea or deep down there in the pool, you feel that okay, liquid is exerting some pressure onto your body. How it is happening? So when we say that okay, liquids are exerting pressure, they exert pressure in all the direction. Yes, even upwards also in all the direction. Particles, let's say this is the particle, right? All around the buoy. Liquid particles are all around the buoy. These liquid particles, they have weight. Right? What is weight? Force. So, weight is nothing but a force that is acting onto the body of the buoy. So, force acting over a particular area will lead to pressure. That is how. Right? Over here, all the particles are all around the buoy. So, he is going to feel pressure all around him. Right? Now, if I am going deep down in the sea, as you can see, more amount of pressure is exerted onto me. Why? Because the number of particles over my body will be more. So, more force is exerted. Have a look over here. right? So if I say this is boy B, yeah, this is boy B and this is boy A. So the particles above, or I would say certainly, the particles that are acting force onto boy A are less. But if I say particles that are acting the force, or certainly applying force onto the boy B are more. So of course, this is simple. Keep your science book over your head, a single book. Okay, but if I will tell you keep hundreds and thousands of science book over your head, difficult, similar way. Okay, so the more you go down there in the sea, right, more number of particles are acting force onto your body and applying force onto the particular area. That is why more pressure we are going to experience. Yeah, now I believe you probably have seen that yes, if you keep a tumbler and fill it up with water and pierce out holes on its side, you can see water jets coming out of it. Why this is happening? The water jets are going to skirt out of the holes. Reason being that yes, water particles, they are exerting force, or they are applying force onto the, or I would certainly say over here, they are exerting pressure onto the side of the walls also. That is why the water jets are squirting out. Similarly over here, more the depth, more the pressure exerted by the fluid. Similar way, if I tell you right now also, atmosphere is exerting pressure onto me. So atmosphere, nothing but layer of gases. Yeah, air around me, air is a fluid. Right now also pressure has been exerted onto me. But I'm not able to feel anything. Why so? Because over here, yes, as the atmospheric pressure is applied onto me, similar amount of pressure is exerted from inside my body, my veins. So it is getting counted up, and yes, I'm not able to feel anything. Okay, now taking this thing only forward, everyone, we are going to talk about nothing but buoyancy. Everyone, there is a huge misconception that buoyancy and buoyant force are same. Buoyancy is nothing but the property. Okay, so have a look over here onto the example. There is a cork. I believe you all have done this thing that okay, you take up a water bottle, empty water bottle, and immerse it there onto your bucket filled with water. Yeah, and you are going to apply force onto it. Yeah, so what will happen the moment you are going to leave it, the bottle will come up. Similarly, if I will tell you that okay, when you are there inside the swimming pool, you tend to feel lighter. How suddenly you are actually feeling lighter? How suddenly, you actually feel that okay, you probably have lost some weight? So, to talk about this thing, first of all, let us talk about buoyancy. So, when we say that over here, there is a cork, okay, held by my finger. So, I am applying force onto the cork and the cork is inside the water. Suddenly, I am removing my hand and ultimately I see that okay, cork is bouncing up, coming onto the surface of the water. Why this is happening? So, first thing over here is that when we are applying the force onto the cork, yeah, it was immersed inside, and the moment I am leaving my hand, something is actually pushing it up. What is that something? Let us understand. So, everyone, every liquid, yes, every liquid will exert an upward force. So, if I say that okay, this upward force that is exerted right now, certainly, yes, right now also if I say no, I'm being specific over here that okay, liquid but gases also, yeah. So yes, right now also there is some amount of buoyant force exerted onto me as well. Let us first understand about buoyancy, then the rest of the things. Okay, so every liquid will exert an upward force, like this, yeah, and onto what? Onto the object that is immersed onto it. So the liquid doesn't want the object to stay over there. This tendency of liquid, everyone, property, yeah. This tendency of liquid that okay, I will exert the upward force onto my object that is placed inside it. This is called buoyancy. Okay, so the property, the tendency that okay, my liquid will exert upward force. This is buoyancy. Yeah. So what is buoyancy? Buoyancy is nothing but the tendency of the liquid. The liquid will say, okay, go up. I don't want you to go through me. Don't pass through me. I will apply an upward force onto you. That is nothing but buoyancy. Okay. Now, if I say that, okay, there is a tumbler in which I am keeping water. Okay. And a ball is immersed in it. right? So logically, if I say right now that okay ma'am, a ball you are immersing inside the liquid, so there is this tendency that liquid will say okay, go up. Yeah, so buoyancy will act. Tendency, property, okay, liquid will say I will exert one upward force onto you. So what is that upward force? That upward force, that okay, you go up. This upward force acting onto the ball or the body immersed in a liquid is nothing but buoyant force or up thrust. Up thrust, or you can say buoyant force. Okay, so buoyant force will be, yes, buoyant force is the force that the liquid will exert onto the body that is immersed in it. Okay, now first thing is clear, right? That okay, this is the amount of force, the force that is actually exerted by the liquid. Second thing, if I say logically, you tell me that okay, over here a ball is there immersed in the liquid. On this force of gravity, or if I say gravitational force will not act onto it. Yeah, or force of gravity, it will act onto it. No, yeah, it will be pulled, right? So if I say that over here upward force is acting onto it, let me just draw this upward force, like on the top, so that you get the clarity, right? This is the tumbler. So this is the upward force, up thrust acting, buoyant force acting, and onto this right now only if I say its weight is acting. What is weight? Mass into gravity. Mass into acceleration into gravity. Gravitation force, certainly, due to its weight, right? Some weight is something with the force acting onto it. Yeah, of course, onto everything this will act. Yeah, force of gravitation, certainly we have completed that thing up. So yeah, I believe till here clarity everyone will have. So everyone, if I am telling you right now a body is there, logically we'll say right now a body is immersed in a liquid, two forces are acting onto it. What are the two forces? One will be the weight of the body, okay. Second thing will be the upthrust that the liquid will apply. Okay, so whenever a liquid is immersed in a liquid or partially immersed in a liquid, two forces are going to act onto it. One will be the upthrust, the other will be the weight of the body. Okay, so now in this scenario, if I tell you that okay, in this particular scenario, now if I find out the F net, the net force will certainly have a look opposite direction, right? F net will be buoyant force minus weight. Now this scenario can vary. I am taking right now buoyant force is more. This can vary. Yeah, as this can vary, this is a general statement. Okay, as this can vary, yeah, the instances will vary. We are going to talk about that, sinking, floating, yes, and floating just above the surface. Okay, this is a general sense. General. My F net will tell me whether the object will go down or at the surface or move up. Right now we are through that okay, buoyant force is nothing but the amount of the force that is actually acting onto the body when a body is fully or partially immersed in a liquid. Okay, and this force will be in the upward direction, the opposite direction, trying to move it up. Talking about weight, yes, weight will be acting in the downward direction, that is nothing but mass into gravity. Of course, acceleration due to gravity certainly acting over here. Yeah, and body is having the mass. Okay, now this thing was actually given some proper words by nothing and no one. You will talk about Archimedes, the one, the great Greek mathematician we say. Of course, he was a physician as well. So, talking about Archimedes, if I say, I believe you all have heard this Eureka story, right? So, yes, certainly here what happened was King Hieron too of Syracuse, he actually said and called Archimedes. He said that, okay, Archimedes, I actually feel that my crown maker, he is trying to make a fool out of me. Why so? Because he said, here, in the particular case, I can see my gold crown, but I don't feel that it is totally and purely gold. I believe that, okay, it is a mixture of silver and gold here. Now, Archimedes was very confused that, okay, king is saying that it is gold and silver mixed. King told him that, okay, you tell me and you take out some of the method that, okay, whether the, crown is actually made up of gold or silver or it is a mixture, you give me a solution. Now, Archimedes, initially, he was very, very confused, but he actually got up the idea when he was trying to take a bath, and when he stepped inside the bucket, he saw that the water is actually flowing out. So from there he got up the idea that okay, whenever, and he stated, whenever a body is immersed partially or completely in a liquid, it will experience an upthrust. First thing. Okay, now which will be equal to the weight of the liquid displaced. So what he did, he actually took out the bar of gold and silver equal to the mass of crown. Okay, then he dipped the gold, some amount of water came out. Then he dipped silver, a lot of amount of gold water came out. Then he dipped crown and he actually saw that a lot of amount of water came out. From there he stated that yes, your crown is not purely of gold, there is some mixture of silver inside it. Okay, so now coming on to the statement, everyone, he stated that first of all, whenever a body, if I say have a look, that there is a beaker, okay, and a snout is there of the beaker, it is filled up with water, okay, and there is another beaker kept. Yeah, so he stated, once again, let me just, another beaker kept. Okay, so inside the beaker, I am dipping fully, let's say, a ball. So what will happen? Some amount of liquid is going to squirt out and get collected there in the other beaker. Now, what my Archimedes is telling me? Okay, Archimedes is first of all telling me that the volume of the object, okay, this volume of the object will be equal to the volume, okay, volume of the displaced liquid. Okay, this actually is stating that okay, over here on the ball some buoyant force is acting. So this buoyant force will be equal to the weight of the liquid that is getting displaced. Getting me, everyone? Yeah, so he's actually stating that okay, whatever amount or whatever is the volume of the object, this much, if I remove this object from here, yeah, so this much amount is the volume of the object, so this much will be nothing but the volume of the liquid displaced, this. Getting? Yeah, this simply stated one thing, that okay, my buoyant force is nothing but equal to the weight of the liquid displaced. Right? Now, as he stated the whole thing up, yes, there was this huge confusion getting cleared, and we actually use Archimedes principle there in the lactometers, hydrometers as well. Okay, there are a lot of applications, yes, of Archimedes principle that we use. From there, we got a certain clarity of nothing but, yes, here, have a look, let me give you a complete clarity. Okay, from there, now let's see, what about the weightlessness, right? That I told you that, okay, you are there in the swimming pool and you feel a bit lighter. How that is taking place? Have a look. My block is, or the weight of the block is 6 kg. Okay, now have a look. When it is immersed there inside the liquid, yeah, so, and when it is immersed inside the liquid, so I can certainly see, have a look over here, the weight inside the liquid when it is immersed, okay, when weight inside the liquid is immersed, right, it is coming out to be 4 kg. That means it is losing 2 kg. Yeah, losing 2 kg. Okay, or you can certainly say that okay, it is losing and there is some amount of loss taking place. Loss in the weight, you can say. Okay, first thing. Now second thing. Second thing is, he stated that okay, the buoyant force will be nothing but the liquid getting displaced. So all of you, when I am measuring the liquid getting displaced, have a look. The weight of the liquid displaced, right? It is coming out to be 2 kg. Yeah, have a look. Loss is also 2 kg. Weight displaced is also 2 kg. Certainly giving me one thing only. No, what is that? Buoyant force. Clear? Okay, if I tell you that volume of the liquid getting displaced, we stated only two things, na everyone? Yeah, these are two things only, no? That volume of the object is nothing but equal to the your displaced liquid volume. Okay, then buoyant force will be equal to the amount of buoyant force action will be equal to the weight displaced of liquid only. Yeah, that is what we are stating and proving. So, the magnitude of the buoyant force is calculated by Archimedes principle only. An object fully or partially immersed in a liquid, it will experience an upthrust, upward force. Yes, that will be equal to nothing but the weight of the liquid displaced. Okay, yes, these things are very, very important. The statement holds a lot of value. I hope till here things are clear. Now, talking about a small thing over here, we are going to have a look upon principle of flotation. Everyone, when we talk about that, okay, principle of flotation, see, it is going to give you the name itself. Yeah, meaning itself, sorry. Yeah, so as it is giving you the meaning itself, let's talk about. See, I told you whenever a body is there inside a liquid, okay, let's say a body is there inside the liquid. Let's take up some cases. Two forces will act on it, right? One will be the buoyant force, one will be the weight. Okay. So, if the buoyant force is greater, what will happen? Everyone, when your buoyant force will be greater than your weight, everyone, let me mark only. Buoyant force is more than your weight, so of course upward force is more like that means pushed into the upward, right? So what will happen? Of course your object will float. Logic, see, pushed upwards. Okay, similar case if I will tell you that okay, when the weight will be more than the buoyant force, then what will happen? When the weight is more, downward force is more, of course the object is going to sink. Okay, now there is one more case. If I tell you that okay, if buoyant force and weight are equal, then what will happen? Everyone, when buoyant force and weight are equal, no? Okay, so your object, that means your object is there experiencing equal amount of buoyant force, equal amount of weight. So certainly net force, if I talk about it is coming out to be 0. Yeah, so your object is going to be suspended as such. We certainly say there immersed in the liquid, but yeah, not above the liquid, not floating. They're suspended just onto the surface itself, like this. Okay, or suspended at a particular depth if it is happening. Okay, getting nullified as such. Okay. So these are the three cases of flotation that usually arises, and of course your buoyant force is actually depending upon nothing but the density of the liquid also. Okay, so yeah, there are some factors that you will encounter. Okay, I believe till here things are clear. So let us have a look on a question. So a body weight 200 GF, I believe you are aware of this unit, in air and 190 GF when completely immersed in water. What is the loss in the weight? First of all, loss in the weight, everyone. 200 minus 190, that will come out to be 10 GF, that is the loss in the weight. Pretty much easy, right now we did. Okay, upthrust, everyone, we know about this upthrust. Weight of the liquid displaced, the loss will be equal to the buoyant force. So of course it will be equal to 10 GF only. Archimedes principle we have done, right? Okay, very simple question. Now this question I have for you, and I want all of you to please go ahead and practice this question. Share your answers with me there in the chat itself. Let me give you the hint, everyone. The area over here is given in centimeter square. So directly you cannot get the answer. You need to convert it into meter square and then share the answer with me. Okay. Moreover, force they are talking about. So triangle. Pressure is nothing but force by area. So force will be pressure into area. Okay, lot of information I'm actually giving you. You just need to put down and convert something and share your answers with me. Of course, I will have a look onto it. Okay. Now, yes, these are some set of questions for you for your practice purposes. Go ahead, practice these questions. Of course, you can share your answers with me. Certainly, I would love to help you out. Very simple questions, very direct questions, and these are the questions that will certainly come in exam. Okay, not beyond this. This is for your practice purpose. I am including everyone. Now, I believe all of you understood till here. Yes, the topic is over. Your whole gravitation is as such over. So, I will be seeing you soon. Take care, everyone. Thank you so much. And of course, keep on practicing and keep on learning. Bye, all of you. Take care.